today we are going to start the new point, that is conformational analysis for a butane. In the last lecture we have studied about conformation analysis for a ethane. Okay. Now in this ethane we have studied about the two conformers of a configuration. First is eclipsed and second is about staggered. Okay. Now according to this conformational analysis of an ethane, we come to conclusion that is the conformers having the less energy and high stability is of which, that is the staggered form, and the conformers which have the high energy which having the less stability. Okay. Now in this sequence again we have to explain here conformation analysis of a butane, but the case of ethane and the butanes are two different ones. But by using the potential energy level diagram versus the angle of a dihedral angle of 0 to 360 degrees, we can explain this conformation of analysis of a butane. See here. For this, in an alkane, the free retrorotation of CC bond axis is possible, but actually it is not possible when the atoms or substituents which are attached within these carbon atoms. That is, the rotation of this CC bond axis is hindered due to some repulsive interactions of groups or atoms which are attached to a vicinal carbon atoms. Okay. Now here with the help of this potential energy diagram which denotes the change in enthalpy of a conformer of a alkane like a butane, we can explain here. First I am drawing the potential energy versus the dihedral angle. The diagrammatic representation like here as this. Here potential energy. Okay. This is on x, the x dash, y dash here. Okay. Here also x, the x dash. Okay. Now coming to this, that is here I am looking this drawing. You have to just now this position, this position, this position. Okay. The gap between this is about 4 kilojoule per mole. Okay. This position is called as syn periplanar. This is called as anticlinal. Okay. This is called as Gauche. Okay. And this position is called as opposite of this, that is anti-periplanar. Gauche or here synclinal. This position is also called as a Gauche. Okay. Now this half and here also this half. Okay. Now the gap between these, that is from this point to this, that is equal to 18 to 25 kilojoule per mole. Okay, and the gap between this and this here, okay, up to this here, it is from here, I am denoting from this position here, that is equal to 14.4 kilojoule per mole. Okay, actually, as this representation, first I am completing this, then I am giving to you the explanation. This is about 0 degrees, this is 60 degrees, this is about here 120 degrees, this is about 180 degrees, this is about 240 degrees, here 300 degrees, okay, and from here also 360 degrees. In this fashion we can write here as dihedral angle. Angle likewise, okay. This is the y-axis, this is also a x-axis. This is the representation of a conformation analysis for a butane. Now what is the structure for butane? See here, CH3, CH2, CH2, bond CH3. This is a molecular formula for this butane. Now the bond of rotation between the central bond, that is the bond between C and C here, this bond is rotated with respect of the attachment of a vicinal carbon atoms of a atoms, that is equal to CH3 and CH3. What are its configurations? What are its configuration at 0 degrees, 60 degrees, 120 degrees, 180 degrees, 180 degrees, 240 degrees, okay, here also 240 degrees, 300 and 360. A complete term shows here how many peaks here. This see periplanar, it is also called as a fully eclipsed. This is called as a partially eclipsed. Partially eclipsed here. This configuration it is called as a staggered. It is also called as a fully staggered, and these are called as, that is the partially staggered. Partially staggered from here. Also it is also called as a Gauchi. Okay here. Okay. Now in this way, as similar to the ethane, in ethane only two isomeric forms of a conformations are possible here, but in case of the butane there is a free rotation of carbon-carbon around its central axis. Therefore we can have how many conformers are here? Racine periplanar, one, this half and this half cuts to a 1, okay, this is of a 1, 2 anticlinal, okay, that is total equal to how many peaks are here? These two peaks are of similar height, and this half is of 1, it is of a different height. That is, we get the two peaks total equal to how many peaks? That is equal to 3 peaks, but 2 are of same height and 1 is of a different height. Similarly, in the staggered conformation also 60 degrees, 180 degrees and 300 degrees. 60 and 300 are of equal height, while the 180 degrees is of different height. Now we are going to explain which configuration have the greater energy, which configuration have the lesser energy, and thereby acquiring the high stability and low stability. Okay, due to presence of a bulky group. Now the point to be noted that here CH3 group, that is alkyl group, acts as a bulky group. When rarer carbon atom of a bulky group is eclipsed by the again bulky group, at that time there occurs a steric strain. Steric strain, and due to the bonding pair electrons of CH bonds which are lie near to each other, due to the repulsive interaction or internuclear repulsion between them, it occurs a torsional strain also. So one by one we are going to express and explaining each of the configuration in detailed form. See here I am writing just by this this time I am writing in the fashion as here. First is about first we have to explain here about a eclipse form. Conformations. First is here eclipsed, and second is about staggered. Okay, in eclipse, how many heads? There are 3 peaks. 3 peaks. Out of 2 peaks are at same height, and 1 peak equal to half peak plus half peak, okay, equal to different height. Now the eclipse angle for the diagonal angles up to, that is equal to, for eclipse, that is equal to fully eclipsed here, fully eclipsed structure, and here on partially eclipsed structure. Eclipse the structure. Now fully eclipsed angles 0 degrees, 360 degrees, and partially eclipsed having the angles 120 degrees and 240 degrees. Okay, this point up to your, this is the primal step. Now we can draw this conformers for 0 degrees, 60 degrees, 120 degrees and 240 degrees here. See here. Now for theta is equal to 0 degrees and 360 degrees. Theta is equal to 120 degrees and 240 degrees. I am showing you here the position as here. First, this is the front carbon atom, already you know. This is the rear carbon atom. To draw here in this fashion, rear carbon atom. Then with the help of the different chalks, likewise here, it is fully eclipsed, theta is equal to 0 here. You can draw here as this, okay. And here, okay. Thus the hydrogens are repeating here. This is H of rear carbon atoms, and this is H of, this is a front carbon atom, okay. Now only I am showing here this theta. That theta is equal to what? Equal to 0 degrees. Okay, that is equal to what? 360 degrees also. This configuration is exists. Again 360 degrees I am drawing to here at, instead of this is writing, this is the front carbon atom, this is the rear carbon atom, this is of this, okay. Sorry, this is the structure for the ethane molecule. We have to keep this, instead of this hydrogen, we have to keep on this which atoms, that is a methane. Here, see here, they are called as a CH3 and here CH3. Okay, now this CH3, okay, this CH3 is of which, that is a front carbon atom. Okay, this CH3 is of front carbon atom, this is the rear carbon atom. Now by fixing a rear carbon atom, we can only rotate the front carbon atom as here. This is CH3, this is H, and this is also H. Now the angle is equal to what? 360 degrees here. You can draw here as, that is 360 degrees. Okay, likewise here also on the 360 degrees again, here which group is, that is equal to this is equal to, theta is equal to 360 degrees here. This is the H, this is also H. Now this H and this CH3 is of a eclipse of theta is equal to 360 degrees. Now explaining this nature, okay. In eclipse form here, rear carbon atom of CH3 group of rear carbon atom is eclipsed by the CH3 group of a front carbon atom. They are lie on the nearer distance to each other, therefore they can create a steric strain. Also the CH, also the C bond and here CH bond, here CH bond of front carbon atom and CH bond of rear carbon atoms, which are situated at nearer distance. Thereby there is occurrence of a internuclear repulsion and causing the strain as a torsional strain. Okay. Now, however, in this position also these two strains are also possible here. That is due to rare methyl group of rare carbon atom, which is eclipsed by a methyl group of front carbon atom, thereby hereby increasing the steric strain also. Okay. Also the CH bond and the CH bond of front and rear carbon atoms are very nearer to each other, due to which bond pairs of electrons tends to occupy the internuclear repulsion between them, causing the torsional strain. Therefore, these structures are not isolated from each other. That is, these two structures remains the same. But this case is not happens in a diagonal angle is equal to 120 and 240 degrees. Now, for 120 degrees, what is the structure? See here, the structure. This is the rear carbon atom. Okay, that is the CH3, H, and here H. And for the front carbon atom, what happens here? That is equal to 120. That is equal to from this equal to what? That is here this called as a Me. Okay, from this position this is called as H, and from this position this is called a H. That is of a theta is equal to 120 degrees. Now what structure is about what? Which angle is equal to 120 degrees? That is about this angle. Okay, theta is equal to what? 120 degrees. Now for the 240 degrees is what? See here, this is the rear carbon atom. Already I have discussed to you. CH3, H and H, and by using the another that is of which angle is 240 degrees. 240 means what? Sorry, this is a eclipse structure, and for 240 degrees here, what is the angle here? That is equal to what here? By using the chalk here as that is equal to 240 here. Okay, now 240 of here CH3 group, here H, and here also H. Now this bond angle, that is theta is equal to what? 240 degrees. Okay, already here the CH3, already CH3 and here CH3 front and rear carbon atoms are having the bonds is equal to what? That is equal to what? That is equal to 120, and here also here which angle? That is equal to a 240 degrees here. Okay, now in this conformations they are eclipsed with each other. These structures cannot be a isolated one because they occupy the eclipse position with a rear methyl group of a carbon atom, which is eclipsed with a front carbon atom of a hydrogen atom. Here also the CH bonds of front carbon atom and rear carbon atoms are situated at a near distance. Therefore they can cause here what? They can cause here, that is torsional strain also along with a steric strain. Now thus the butane molecule acquires the steric strain in a higher amount. To attain the stable structure of butane, it absorbs extra or acquire extra 18 to 25 kilojoule per mole of a energy to get a stabilized one, or the atoms of the other atoms of the butanes try to strike on the walls of the container in order to achieve the what? It is the stable conformation structure for a butane 1. This is the case for which, that is the by a eclipse structure. Now go for this staggered structure. What is up here? Here in the staggered structure there are also similar sequence. Likewise the which here staggered, that is theta is equal to what? 60 degrees, and here 300 degrees, and theta is equal to what? 180 degrees. First we are going to explain the theta is equal to 180 degrees. The structure is as follows. This is the front carbon, this is the rear, this is also a Me. Me stands for which? That is in short of a CH3 group here. Here H and here also H. Now in the staggered form, how it is? We can write here. This is the now in this way we can write here. Now the front carbon atom of methyl group is just opposite to the rear carbon atom. For this bond angle, that is theta is equal to what? 180 degrees. Okay. This is the configuration of a staggered in case of this butane molecule. Therefore, it acts as the two methyl groups are totally opposite. By I am taking the angle of a theta is equal to 180 degrees. Therefore, this CH3 group of rear carbon atoms and front carbon atoms lying longest distance to each other. Therefore, they can cause the less steric strain. Less steric strain. Again, by the CH bond distance of a rear carbon atom and the CH bond distance of a front carbon atom is at also a longest distance, thereby minimizing the internuclear repulsion between them. Also, there is a less torsional strain. Therefore, this structure is having the very less energy and it is a more stable one. It is also called as a fully staggered structure. But in case of theta is equal to 60 degrees and 300 degrees, this case is not possible here. See here the structure. What are the structures? This is the front, this is the back carbon atom. This is the system here. This is Me, H and H. Here also. Now in case of this, that is theta is equal to what? 60 degrees. Here Me, that is this theta is equal to what? 60 degrees here. Here H and here H. For 300, see this is the forefront, this is the rear carbon atom. See here Me, H and here H, and of 300 degrees. Therefore, here this Me and this Me, this bond angle is equal to 60 degrees. Here Me what? See here 300, that is equal to what here? Here 240, here 300, here this is equal to Me and this is equal to H, this is equal to H. Now this Me and this, that is this bond angle is also equal to 60 and this angle is about is equal to what? 300. Therefore, each of these theta is equal to 60 degrees or theta is equal to 300, which are the conformations are equal to the same conformation. Therefore, these conformations cannot be distinguished from each other. Therefore, they are dynamic in nature. But due to the methyl group of a rear carbon atom and the front carbon are situated at a longer distance, not a longer distance than this, theta is equal to 180. Therefore, they can cause the less strain. Less strain. Here also, this case is also possible. They also cause a less strain. Also, due to the CH bond distance of the front carbon atom and that of rear carbon atom, front carbon atom and rear carbon atom, it is situated at a longer distance, thereby minimizing the internuclear repulsion between the electron pairs of a bonding pairs of CH bonds. Therefore, there is a less torsional strain and thereby acquiring the stability which is less than that of the theta is equal to 180 degrees. Therefore, this conformation is also called as a stable conformation. But in between 60 and 300 and 180, which is the more stable? That is, this is the more stable. Now, what about the structures between 0 to 360 other than the structures? That structures are called as the skew structures. See here. skewed structures, which are the conformal structures with dihedral angle other than theta is equal to 0, 60 degrees, 120 degrees, 180 degrees, 300 degrees, sorry, 180, 240 degrees, 300 degrees and 360 degrees. The conformation is called as a skew conformation. Okay, here. Now for this skew conformation, what are the structures are here? Okay, see here. The structures are as possible here. That is, skew structure is like this here. From here, this is the front carbon atom here. Okay, that is MECH, H here also, and on skew type here as like this. Okay, that is here Me, here H, and here H. This type of structure is called as a skew, which is the intermediate structure between the eclipse structure and staggered structure. Okay. Now, whatever may be the skew structure having the physical and chemical properties which are in between eclipse structure and staggered structure. Okay. Now, what about its stability? Now, between the eclipsed, partially eclipsed, then skew, then also, okay, then partially staggered, and here fully staggered. In between all these, the most stable structure is about fully staggered, because it acquires a less, here acquires the less energy, and here I've got the high stability. Okay. Now at normal room temperature, that is at 25 degrees Celsius, that is at 298 Kelvin, the average energy required for all the repulsions, that is equal to what? That is equal to 63 to 84 kilojoule per mole, which is sufficient to overcome the energy barrier of a of a strain due to the bulky CH3 group and the other strains also. Okay. Thus, here the most stable structure is equal to fully stable structure, and less stable structure is equal to what? That is the which structure? That is the fully eclipsed structure. That is having the less stability. This is stability. This is here, and this is of here. Okay, that is fully stabilized structure is equal to what? That is the fully staggered structure. But at 298 Kelvin, here all the eclipse form, that is eclipse, the partial eclipse structure, fully staggered structure, partial staggered structure, they are interconvert to each other. Therefore, it is a dynamic equilibrium. Okay. Therefore, we can't isolate separate eclipse structure as a separate one here. Okay. Thus, we have explained here conformation analysis for a butane. Now, one by one, we can draw the structures for this is as follows. That is, for eclipse structure, see here. What is the fully eclipse structure here? First, it is like this. This is the Me. This is H, and this is H. Here also H. This is of H, and this is of also A. This is Me. This is H. This is the fully eclipsed. Partially eclipsed what? That is equal to theta is equal to what? 120 or here 240 degrees. This is Me. This is H, and here partially eclipsed what? That is 240 degrees. This is okay. Then this is, and then this is okay. Here Me group H, and here H. Skew conformation is what? Here dot. Here this is here Me, H and H, here H, H and then this Me, H and here H. This is the skew. Partially staggered means what? That is 60 degrees and here what? That is the 300 degrees. This is Me, H, H. Here also 300 degrees means what? This is from here, here Me, H and H. This angle is comes to be 300 degrees. And for fully staggered structure, what is the structure? Which is the most stable structure, that is equal to what? See here, this is the structure of this Me, H, H and here like this. That is about, what is the angle? That is Me, 180 degrees here. Theta is equal to what? 180 degrees here, H and here H. This is the most stable structure which can exist in a, as a having a less energy and high stability one. Thus we have explained here the conformation analysis of a butane. Okay, I hope that all of you understand this video very carefully and please ask if any are doubts. Okay, thank you.